Diode Power Multiplexing. What is power multiplexing and when would you want to use it? Power multiplexing is used on almost every modern electronic device and is basically used to safely connect the device to multiple power sources. For example, a cell phone can get power from either USB or battery. However, if the battery and USB supplies were connected directly, the USB voltage would be too high for the cell phone battery and damage it. We can use power multiplexing to power a device without shorting our supplies together. Diode power multiplexing is very simple. Taking the example from earlier, we use two diodes with the cathodes connected together to the positive end of the load. The anodes are connected to the power supplies. When the USB supply is connected, the USB diode is forward biased with a voltage drop of roughly 0.7 volts, making the load voltage 4.3 volts, so the LiPo battery diode is in reverse bias and will not conduct. However, with the USB voltage disconnected, the LiPo diode is forward biased and the load voltage is supplied by 3.5 volts. When designing a diode power multiplexer, you'll need to decide whether to use silicon or Schottky diodes. Silicon diodes have a clear advantage with battery multiplexing because the low reverse current prevents the reverse bias battery diode from accidentally charging the battery from another power source. For example, if the current from the USB power supply leaked into a fully charged LiPo battery, it would damage the LiPo battery and shorten its life. Silicon diodes are also good for high voltage applications where the blocking current is a more important consideration than the voltage drop. Schottky diodes are an excellent choice for low voltage applications where the 0.7 volt drop of a silicon diode is just too large. They are also good in high current applications since they dissipate less power than the silicon diodes. This often means that you can use a smaller Schottky diode package to achieve the same currents, since the power dissipation is around half of a silicon diode. In the final video of this diode series, we'll look at how diodes can be used to turn AC voltage into DC.